Okay, today we're going to talk about the shell method, which essentially means, what essentially is happening is we're going to take those rectangles and we're going to rotate them about the other axis, okay? And we're going to focus on both X and Y axes today, and then tomorrow we'll focus on like the different lines, like Y equals 2, X equals -4, those kinds of things. So we need to talk about how these are different, okay? Now, Michael, you were explaining to Catherine how our rectangles are. You said that when we made discs, our rectangles were what to our axis? Perpendicular, okay? Now, in this picture that I drew on the board, what is this rectangle in relation to the axis we're rotating around? Parallel. Okay, so we need a way to keep this straight. Okay, today I'm going to teach you the shell method. We know the disc method. Washer, disc washer. Okay, those go together. Okay, are you ready?
There's an L in shell.
What?
There's an L in shell and also in parallel.
You're taking away all my glory. I would like you to remember this as the well, I like this. that doesn't sound very good, right? Okay, so, but perpendicular, we can remember that, right? Okay? Okay? I am going to call the disc method the perpendicular method because we need those rectangles to be perpendicular to the axis of rotation. Now, in our shell method, we need them to be parallel. So if you need a way to remember that, they need to be parashell. What's awesome, though, is that some of you guys came up with that before I even said it. So, oh yeah, a little drawing here. Okay, so we're going to take these parallel rectangles and we're going to wrap them around the axis of rotation so we get all of these hollow cylinders, or we get these shells, or Russian dolls, whatever you want to think of them as. Okay, but we partition our region into infinitely thin rectangles and wrap those around. Okay, so I need you to really imagine these rectangles wrapping around. Okay, imagine you for you here. But it's important for you to imagine so you know now which method that you are using. Okay, we're making shells here. Okay, so let's think about these shells. You said they're cylinders, right? But they're hollow. Okay, so if I take this shell and I cut it, and I lay it out flat, let's talk about what all of those measurements would be. Okay? Yep, it's going to look like a rectangle. Okay. So we're going to cut it, we're going to lay it out flat, and it looks like a rectangle. Okay? So let's talk about what the measurements are going to be of this rectangle. You don't need to draw this, we're just going to think about it. Okay? Now, I've already told you that this is the height of our cylinder. So this is probably the height, right? Let's talk about the length. That's the most important. The length of our cylinder. If we took, or this rectangle, the length of our rectangle, if we took that cylinder, cut it, and laid it out flat, what is this measuring? Circumference. So this is 2 pi r. Okay? So that's the circumference of our circle. We have our height, and then of course we have our width, which is, in this case, dx, or when we get there, dy. Okay? So if we want the volume of this cylinder, we cut it out, and it's really the volume of this rectangular prism. We know to find volume, we would need length times width times height. In this case, 2 pi r times width times height. Okay? That's how we're going to come up with our formula. Okay? Now, and I'll reference this picture right here because my picture on the next slide, it has a lot of arrows, okay? If I reference this picture right here, when we rotate this around, okay, our radius is going to be how far away are those rectangles from the axis of rotation, okay? And our height is going to be what is the height of the rectangle, okay? So let's look at this here. Okay. And we have a cute little drawing, like look at this. Here's your Russian dolls, like all put together for you. Okay. Just take that in for a moment. Isn't that fun? I think it's fascinating. Okay.
Yeah.
What?
Said it looks like a coliseum, but we don't want to not say Russian dolls.
Okay. Okay. So what we're working with is our radius of these cylinders, right? It's how far away they are from the axis of rotation. And the height of our rectangles gives us the height of our shells. Okay, so how do we find the height of those shells? Top minus bottom, okay? And if I'm rotating around the y-axis here, how far away are each of these given rectangles from the y-axis? X. These are all, because we don't have, we have a bunch of these, right? Okay, well, we measure horizontal distance by X, right? So they're all X units away because we don't know where they're going to be. Okay, so here is our shell method when we're rotating about the y-axis. Go ahead and write it down and draw these arrows. X is our radius, f of x minus g of x is our height. Okay, so we still have our concept of top minus bottom. Okay, notice how there is a 2 pi out in front. Okay, what I want you to remember is 2 pi RH dx, or 2 pi RH dy. That's what I want you to remember. So if you want to write that, let's go ahead and do that. 2 pi RH dx. Okay, I would probably write that somewhere because tomorrow our radius is going to change. Okay, when we rotate around a different axis, our radius will change, but we're not going to worry about that right now. Okay. All right. So now we really have to be careful with drawing our pictures and understanding if we have shells versus disker washers. Okay. So we're actually going to find the volume of this particular region that we're rotating around the y-axis. Okay, and these are the boundaries for the region. Y equals 1/2 x, and y equals 1 minus x, the quantity squared. That really does look like a coliseum, right? Hey. What's happening? Okay. I am going to have to delete it so we can actually draw it, so I apologize. What?
Looks like the cone of shame, like for dogs.
Oh, I was like, what is it called?
No, it's looking.
Like when dogs get, like, have to, yep. Okay, so let's just talk about how we would get this region. We all know what it looks like right now. But y equals x minus 1, the quantity squared, is a parabola shifted. The right one. Okay. And then y equals 1/2 x is a line with slope 1/2. Okay? And we are going to rotate this about the y-axis. And since I'm asking you to use the shell method, we know we need parallel rectangles. And we know they have thickness dx. Okay? I need you to be able to look at a rectangle and know whether its thickness is dx or dy. So since this rectangle's thickness would sit on the x-axis, its thickness is dx. Okay? Okay. Let's worry about our limits of integration here in a moment. Okay? We know that to set up our volume, we need 2 pi r h times the width. Okay? So our radius. How far are each of these rectangles from our axis of rotation? X. They're x away. Okay? Times the height of our rectangles. Well, we just have to do top minus bottom. Our line is our top function. Minus our parabola is our bottom function. Okay? Now for our limits of integration. Can you just look at that and know what they are? You know what they are? Did you get that from your calculator? Okay. If we did the algebra here, what do we have to actually do? Okay, we have to multiply this out, right? X squared minus 2x plus 1. Which means we have x squared minus 5/2 x plus 1. Okay? Now, I don't know about you, but factoring with a fraction, like, doesn't really sound enjoyable. I mean, we could do it, right? We could do it. But if you don't want to factor with a fraction, multiply both sides of the equation by a number. Are we allowed to do that? You betcha. We could multiply by 2, 2x squared minus 5x plus 2, and now we have something that's a little nicer to factor, right? X times 2x minus 2 minus 1, 1/2 to 2 are our limits of integration. It's actually really nice to factor. Okay, so here's our setup. Same thing as before. Do your integral without the pi. And I don't know if you want to do it without the 2. I'd probably be tempted to put the 2 in there, so then you only have to put the pi on at the end. Okay? So do the integral without the pi. If it's a fraction, then we can just tack on that pi. So go ahead and use your Math 9 command, to find that for me. we get a fraction? 9/8? Do we agree with 9/8?
Let's multiply it by 2.
Okay.
Wow, okay.
Okay. Let me do. No. You don't have your x in there. So 45 over 32. Right? There's your rock. You close your parentheses to it. Like, hey, cross that. Like you have x multi times 1/2 x. You see what I'm saying?
Yeah.
And that's why we practice using our calculator during class. Sometimes some of you are like, oh, I know using a calculator. Okay, order of operations is important. Okay, so practicing with your calculator throughout both in class and your homework. Good idea. Okay, go ahead and write down these pieces of given information. Our region is y equals 0, y equals sine of x from 0 to pi. Well, that's nice. Revolved around the y-axis. Okay, there's really no guessing about what our limits of integration are on this one. It's basically telling you. Okay, so go ahead and write down the information you need to, and then we'll create our picture. Oh, that is perfect. Oh, I'm just making this work. Okay. There's our region. I was trying to like highlight it for you and then I need to fix my projector. It's all wonky. Okay. So here's the sine of x from 0 to pi, also bounded by y equals 0. Okay. We're going to take this and we're going to rotate it around the y-axis. Now, some of you may feel, oh, I really like that disc washer method. So how about I go ahead and draw in this rectangle? What's the issue? Okay, and can I put that function in terms of y and it be legitimate? No. The inverse sine function only goes from negative pi over 2 to pi over 2, so that's not going to work. Okay? So, can I erase this without doing anything? Okay, so we don't have a choice whether we want to or not. We have to use vertical rectangles, okay? Because we can only do this with respect to x, which means we are creating shells around the y-axis, okay? So shell method makes me think 2 pi r h times thickness, okay? Our radius. How far away are our rectangles from the y-axis? X. Then we have to think about what are the heights of each of our rectangles. Top minus bottom, what are the heights? And then our limits of integration 0 to pi. They give that to us, right? Yeah.
Is there ever gonna be a scenario where the radius doesn't equal x?
Tomorrow there will be. Okay. When we rotate around an axis that isn't the x or y axis, it will change. Okay. So we'll focus on that tomorrow. Okay. I am guessing that you're not going to get a nice fraction out of this. Am I right? A nice irrational?
Yeah,
What is it?
I got pi. If you don't multiply by 2 pi, the area is constant.
Okay, so essentially you're saying that this is 2 pi squared? Okay. Okay. Now, if you notice that that is pi before you multiply by 2 pi, I mean, go ahead. You feel free to give me 2 pi squared, but I'm totally fine with a decimal in this case. Jackson just made an observation that the integral without 2 pi was 3.14, blah, 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 blah. Which, can I tell you how disappointed I am that spring break happens over Pi Day? We don't even celebrate Pi Day in class.
You can't even celebrate Cow Day because it's
Okay, what do we get for our decimal? 19 point what? Okay. I love Pi Day, and I think this is the second year in a row it's come during spring break.
Yes.
We
Don't
could.
bring pie.
Free Friday.
Okay, now that is the day of our test, I will warn you.
We could bring pie and eat it during the test.
It was giving me brain.
Ready? Okay.
other students use songs.
Okay, last example. Last example. Where we can only bring food that resembles a region that has been rotated.
Oatmeal cream pies. They're pie. I have a bunch.
We'll plan this later. We'll plan this later. You got very excited. If we wouldn't have had snow days, Mr. Grable and I have a lab where we actually find the volume of a butt cake using this stuff. But with our snow days, we're not going to.
Instead of the test.
Instead of the test.
It can be some of it. I know.
As you're writing this down and trying to talk your way out of taking a test, I will let you know that of the 6 AP questions, 1 of them will involve area and volume, like full of it. Okay. So taking the test would be a good idea. Okay, so we have y equals 4x and y equals x squared. So 4x and y equals x squared. But we're rotating it about to the x-axis. Okay? Today we are focusing on the shell method. So what type of rectangle do we need to draw?
Parallel.
A parallel for our parashell, thickness dy. Okay, so now I'm showing you how to do the shell method with, in terms of what? Okay, so first of all, let's go ahead and rewrite our functions. Instead of y equals x squared, this would need to be x equals radical y, and it's just the positive side, so we don't need to worry about plus or minus. And then the line over here would be x equals y over 4. Okay. We're still going to set these up the same way. 2 pi r(h), this time dy. Don't write r and h because I'm going to erase them. Okay. Our radius will always be how far away our rectangles are from the axis of rotation. Now, in terms of y, what is our radius? Y, okay. And then the height of our shells this time will be right minus left. Okay? So our right function is radical y, and our left function is y over 4. Ooh, limits of integration. Hold on, hold on, hold on. Some of you know, some of you don't. Just hold on. First of all, we got to be in terms of y. Okay? So it's easy for us to want to say 0 to 4. It's not. It's 0 to 16. Okay? If you don't see that right away, we need y over 4 to equal radical y. And then we would need to solve that out. What I would probably do is write y equals 4 radical y, or y squared equals 16y. And figure it out from there. Okay. So we have 9 minutes left in class. What I would like you to do is I would like you to reference your gold sheet, get a book at your table, and I want you to set up 2 problems before you leave. Okay? They don't have to be the first 2 problems. They can be any 2 problems, but I would like you to set up 2 of your homework problems. Not necessarily solve, set up.